Hello everyone, I'm Aratrika Sengupta from University of Florida and I'm working on a project for image processing and computer vision. My project is based on automatic detection of traffic sign with the aid of image processing. The objective of the project is such that it aims to research the current technology for recognizing road signs in real time from a moving vehicle. The most promising technology for intelligent vehicle systems is vision sensors and image processing, so this is examined most thoroughly. Now the purpose of this project was to separate the stop sign and the yield sign from each other. This work used basic image processing technique to automatically recognize different traffic signs. Here the emphasis will mostly be on stop and yield sign, which are both red in color. Before we go into the algorithm of the process, let's see the basic structure of the process which is involved in the image processing and recognition of the traffic sign. This includes 3 steps. The first being pre-processing. As we see from the block diagram, it will load the image as well as check contrast, brightness and clarity. So if these parameters are off from our desired values, adjustments will be made. The next these adjustments will actually allow the design team to be able to ensure that the image is suitable for processing. If the software cannot obtain the contrast or brightness needed, it may not be able to identify if there is a sign in the image or not. The second step is the crucial step, which is the image processing and the recognition. The block diagram to it has been shown beside. So this block will process the actual image to find the region of interest where the sign is located. First, the system will detect colors and then look for colors of interest. Here, since stop sign and yield sign both are red in color, so red is the most important component. The image is then processed and the system will then define the region in which the color is concentrated and outline the shape of the traffic sign. In that case, if no sign is present, there will not be any sign to identify and hence there will be nothing or an error, which will be the output. This output is the final output is actually shown by a conditional block diagram. So it first processes and detects whether there is an image present or not. If it's present, then it will highlight the edited output image, and if it's not there, then the output will be nothing. So here we come to the flowchart of the algorithm that has been used in this project for the traffic sign recognition. As we see that it includes 3 basic steps. First, the separation of the red color by thresholding in the RGB domain, removals of the regions that are either too small or too large, also removal of region for which the ratio of the major axis to minor axis is too large, and finally the separation of the stop sign and the yield sign by thresholding on their filling ratio. Now, before we go into improving the robustness of the RGB thresholding, let me tell you that the data used for this method are collected by a regular consumer level camera from real road. There are actually total of 65 images collected. Among them, 52 images have stop sign and 13 has yield sign. All the images are resized to 640 by 480 size. When selecting the images, there is only one image which is selected from one traffic sign, so that the detection result won't be biased by the repeated images on the similar scenes. Those images are further divided into 2 groups, the training group and the testing group, in which the training group has 45 images and the testing group has 20 images respectively. The training group are used to select the proper thresholds for the detection algorithm, and testing group is used to test the effectiveness. The training group has 37 stop sign images and the yields and 8 yield sign image, while testing group has 15 stop sign images and 5 yield sign images. Now So let's now discuss about the first step of the algorithm, which is the RGB thresholding. The RGB thresholding, instead of being thresholded on the three different colors, that is the red, green and blue, it is thresholded on green to red ratio as well as blue to red ratio. This is because this process has a drawback that the thresholds are affected by lighting conditions of the image, thus making it difficult to find the universal threshold set which was actually applicable on images with varying lighting conditions. Hence, instead of directly thresholding on blue and green domain, the thresholdings are done on those thresholding on these two components are applied as the ratio of the corresponding component to the red component. Hence, this process turns out to be less affected by lighting condition than the original scheme and provide better segmentation result. The next process is the second step of the algorithm, which includes the removal of the small and the large region. The small regions mostly includes the noise, vehicle tail light cover, road pavement, etc., and the large region include the large red background or maybe a brick wall. So here, to do this, first we remove the region that is too small, which might come from the noise or from small random object. As a result, the traffic won't be detected if it is too far away from the observer. The region that is too large is also removed, and then image dilation is used in order to connect together the possible fragmented parts of the traffic sign after thresholding. Since both the sign, that is the stop sign, and the yield sign, both have the major axis, ratio of the major to the minor axis close to 1, so we can say that any of the axis ratio which is far beyond 1 or far lesser than 1 can be removed, considering them as a larger area or a smaller area. For example, we have shown in this image itself that here the red pole at the corner of the right hand side corner of the picture has been detected by the RGB thresholding. However, it would later be removed because the major to the minor axis ratio is large for this one. Finally, the final step of the algorithm for the filling ratio includes the filling ratio. The filling ratio is nothing but the ratio which is used to determine the stop sign and the yield sign from each other, where we see the stop sign tend to have a larger filling ratio than the yield sign, owing to it being the octagon, whereas the yield sign is triangular with the empty triangle inside. Here we see that the filling ratio for stop sign is 0.82 and that for the yield sign is 0.56, which gives a proof that actually stop sign tends to have more or larger filling ratio. The threshold selection is actually done so that the training data is used to choose the thresholds of the algorithm. For each image, manually select an area of the traffic sign, record the properties. The properties are mostly the minimum, the lower and the upper boundaries of the red, green and blue components, as well as the mean of the ratio of the green to red component and the blue to red component. So we select the threshold so that the traffic signs in most of the training image can correctly be segmented out. For this project, the threshold selections are taken as this, where the minimum of the red component is 70 and the maximum is 260. For the minimum of the green and blue are 0, whereas the maximum for green and blue are 0.6. The minimum size of the pixels are taken as 60 pixels and the maximum as 60,000 pixels, with the filling ratio as 0.6. So here I have also shown the percentage of the percentage of the detection rate that has been analyzed by this algorithm. So this algorithm, the first table shows the detection rate for all the images, whereas the second table shows the detection rate for the testing images. Here, false detection means the other foreign objects that are mistakenly identified as either stop sign or eel sign. So we find that this algorithm gives a correct detection rate of above 80% on the selected image group, suggesting that this algorithm can provide some basic recognition capability, if not ideally. So finally, we have shown the step-by-step stop sign detection by this algorithm, where we see that the original image after RGB thresholding has few of the larger or the smaller area, which are again filtered by removing the small regions, and then finally after dilation we find that the stop sign has been already identified. Finally, it is compared with the filling ratio, and then the final stop sign is obtained, thereby removing all the other areas or the regions which have filling ratios lesser than the given filling ratio of the stop sign. Similarly, we have shown the eel sign detection here also. In fact, I can show it over the MATLAB. This four values are the threshold region mapping values, which has been used for selecting the area of the given stop sign or the eel sign. So here we obtain the final output, and we see that this is the final executions which show that the final stop eel sign has been detected by this algorithm. This is the threshold area where it actually removes any of those regions which have values higher or lower than the given filling ratio threshold for the eel sign. This is the selected area. We see that it has been selected originally. This values are actually used for mapping the selection of the area. This is the original image, and these are the RGB thresholding, where it actually thresholds in order to identify the region of interest for the region of interest for region mapping. So hence we see that this algorithm works fine on both the training and the testing images with a detection rate above 80%, although there are some cases where the algorithm either fails to correctly single out the sign region or falsely remove the sign region. In one case, the stop sign can be falsely removed because it is connected to a red pole where the ratio of the major to the minor axis is really large. In the other case, the stop sign is not picked up simply because it is too dark. Here we see that since it is dark, it cannot really distinguish between the other colors. And here, since it has since the stop sign is actually connected to a red pole, whereas there is a red car also, the image couldn't really focus on the removal with the removal of the area with the help of the major to minor axis ratio. So this images gives the future researchers a room to improve the algorithm. Finally, this algorithm achieved about 80% correct detection rate, as we have seen in testing image and in whole image group as well, thereby proving its capability in order to detect stop and eel sign. That's all for my project. Thank you.